Yep, I'm ready.
Okay, and now I will give the opening remarks. Welcome to today's Dapp Learning sharing meeting. We maintain an open source Dapp development tutorials on GitHub. We hope we can not only give junior developers an executable and simplest blockchain Dapp Learning roadmap, but also present advanced developers with a platform for communication and cooperation. Today, we invited Chris from SafeStake to give us a presentation and also an AMA. Now, let's welcome Chris.
Well, good evening, everybody. I want to say thank you for inviting me to give a presentation and tell you guys about SafeStake. It's an honor to be here. And just to tell you a little bit about SafeStake and Parastate. Parastate is the kind of the DAO, the overseeing organization, and SafeStake is the project that we'll be talking about today, which is a decentralized staking infrastructure and protocol, and it brings some exciting things to Ethereum staking and ETH 2.0. And without further ado, I think we'll go into the presentation. So I'm going to go ahead and share my screen. Let's see. Oh, give me 1 second here. Sorry. Let's go ahead and share this. Okay, can everybody see my screen?
Yes.
Okay, great.
Yes, we can see your screen very clearly.
Excellent. Okay. So again, you know, kind of to put this a little bit more clearly, SafeStake, as you can see here, is a trust minimized middle layer that fosters the decentralization of ETH 2.0 staking. What we mean by that is with our system, the operators and the people that run it run independent nodes, and they don't need to sort of trust each other in order for the whole system to work. So it's a very interesting system and protocol. Let's get into a couple of things here. The purpose of this discussion, I want to talk about ETH staking and some of the risks that go along with it. I want to talk about Lido and Rocket Pool because they're very popular right now. Look at how they handle staking, and I know that your community sort of, you know, wanted to see, you know, what they're doing versus what we're doing. So I'm going to kind of position it that way, and I'm going to talk about how SafeStake takes staking to the next level, makes it a more reliable, secure, and ultimately flexible way to stake ETH and keeps the Ethereum ecosystem, if you will, and infrastructure decentralized. So from a high level, what is ETH staking? You know, some of you guys are probably real familiar with this, some may not be, but this is, you know, Ethereum's proof of stake mechanism that replaced mining. So instead of the mining mechanism that was in place to produce new blocks, we've got our validators in place, securing the network, signing data transactions, and you know, making sure, making sure that you know, the network stays secure. The validators, they work by funding, so the user puts in 32 ETH, they deposit it into the smart contract, and they can run a validator. You know, they're putting their 32 ETH at stake, hence that term. And, you know, the validators out there getting data requests from the beacon chain and validating those and sending it back, and that's producing your new blocks. And coming to consensus in the background. So when a validator performs its duties correctly and on time, the beacon chain sends a small amount of ETH to the validator. And that is the whole point, right? Why run a validator unless there's some reward mechanism in there, and that's built in, and that is what we're talking about. So what's going on in the industry because of that is, the merge happened, it's complete, it is working, there's nothing left to prove, and the validators are doing their job. So the market is starting to see that. And even before, I mean, staking was huge. When I got into staking, I don't know, there was a couple 100,000 validators on Ethereum network, and now there's, I think, upwards of almost 500,000, if not more. I haven't checked the latest, but it's close. So people want to get a piece of this industry, and staking services are popping up everywhere. Letting people deposit their ETH and make money. And two of the biggest ones out there in the staking pool arena are Lido and Rocket Pool. So, with all of this happening, excuse me, with all of this happening, how we see it at Parastate and the SafeStake project is the need for a robust, scalable solution that allows users to safely and reliably stake their ETH in a decentralized way that keeps the network decentralized. And why do we need this? Because currently the risks of staking are just too high for many users. Let's talk about what some of those risks are. So the big thing that comes into play is validators being online. Of course, you get your rewards for doing your job correctly if you're a validator, but if you're offline or something is faulty and the validator can't respond correctly or on time, they're going to get penalized. So these penalties happen in deductions of small amounts of ETH from the balance of the deposit, and that's for validators that are staying offline for short periods. They miss a couple of attestations or things like that. There's a small penalty, but it's not a big deal. They'll come back online and they'll start making their money back. But if the validator stays offline for extended periods or acts maliciously, does something on the network it shouldn't do, then slashing comes into play. And in that case, we're talking about bigger amounts of ETH being taken away from the 32 ETH balance and can actually be slashed right down to zero. So that's a big thing. If you're going to spend the money, invest in a validator, you want to be sure that it's gets slashed down. And just to talk about this quickly, we'll get into it a little bit more. But right now, the instances of slashing mostly have come from operators and other people, nodes and whatnot, trying to run a redundant configuration so that their validator is always online. And what they do, what they've tried is to run it on two different machines, run the same validator key on two different clients. And if they both respond when a call goes out, the Ethereum network, frowns upon that greatly and, basically slashes the validator for doing that. I'm sorry about that, guys. My fingers are touching the keys where they shouldn't. So that's a big thing. And then security, with the current way that things are staked, you have to have your validator key online and stored somewhere. A lot of validators use, AWS, Amazon Web Services, or some other cloud service, and that key is online and exposed. So, that in and of itself can present some security issues. So, after taking a look at some of those, now that you sort of understand what some of those risks are, that have been identified and that people are working on, that projects like ours are out there to solve. Let's take a look at the two big guys out there right now. We'll start with Lido, and essentially Lido is a staking pool that allows any amount to be staked. So it gets rid of the 32 ETH minimum requirement, if you will, that you would normally need to run a validator. So they're sort of taking these these pools of ETH that people are staking, and they're sort of crowdsourcing validators with it. And nobody has to operate or maintain anything from an infrastructure standpoint or a technology standpoint. So you can be, basically completely zero knowledge about staking and use, a solution like Lido or Rocket Pool or us. And that's what we'll get into. So that's what really staking services are offering is that ability to do it without having to know how, really. So Lido is DAO based, meaning when users deposit their ETH, it goes out to some node operators that are members of the DAO. It's a relatively small pool. So, that kind of thing comes into play with regard to how many are actually, out there operating validators. In this case, stakers receive staked ETH, which is an ERC20 token representing their deposit and any rewards and penalties that their validator incurs. So it's sort of a one-to-one on the ETH that's deposited. You get this ST ETH token, and then that's a liquid token. You can sell it, and you don't need to wait for the Shanghai update to happen, which will release validator deposits and allow withdrawals there. And that's in the future. Not really sure when that's going to happen. As a fee for all of this, Lido is going to keep 10% of the commissions generated from the profits of the validators. So pretty standard stuff there. This is right from Lido's, Lido's website. Really what their solution is solving is the whole Shanghai update issue with sort of validator funds being locked up and inaccessible, unmovable until that update happens, when you could take your 32 ETH out and cash it in if you're running a validator. So this allows staking with liquidity, essentially. Some of the shortcomings, as we see it, it sort of lacks decentralization in the sense that, as I mentioned, the node operators are limited in number, creates kind of a centralized staking pool. And if one operator goes offline or does something they shouldn't do, it ends up affecting a lot of validators. So that's a little bit of an issue. In addition, solutions right now, basically all of them, and this is, I'm going to show you how SafeStake comes in and sort of solves these things, is redundancy, fault tolerance, and enhanced security. Because we're running on a single node, we can't have redundancy or fault tolerance. And we talked about, the security issues with keys being, exposed and online. And then the other thing that was hard to say 100%, and maybe you guys actually might know the answer more than I do, I'm not sure, but are they custodial, non-custodial, semi-custodial, meaning are they keeping your keys and your withdrawal keys and things and sort of controlling that? Is it somewhere in the middle, or is the user retaining all of that in the background? it was hard for me to find it, and I'm not really sure. All right, let's take a look at Rocket Pool, another big solution, as you guys know. This Rocket Pool, you know, is more, they're saying more of an infrastructure service and pool. Anyone with as little as 0.01 ETH can stake, and also doesn't need to know any tech. And if you want to stake and run a node, which normally would be, excuse me, 32 ETH to deposit into the contract, they only require 16. So essentially you're pairing up with another user of 16 and creating a validator for the 32. Again, when you deposit ETH into Rocket Pool contracts, they're going to give you this token called RETH. It's also a liquid staking token representing the deposit, all your earnings. You can sell it, all that kind of stuff, trade it. Excuse me. It's a non-custodial staking solution. Users do retain full access to their deposit, their keys, both the private and the withdrawal. Features a decentralized network of node operators, and in this case, Rocket Pool itself doesn't take a cut of validator earnings, but the node operators that are sort of keeping the infrastructure up and running the software and protocol, they get commissioned somewhere between 5 and 20%. The protocol sets it probably based on their performance or something like that. Some of the shortcomings here, really, you know, it's a little more decentralized. So really, we're talking about single node kinds of things. Redundancy, fault tolerance, enhanced security. They really don't have that because of running validators on one node and one node only. Let's see here. Let's get into SafeStake. Let's talk about how it is similar but different, and how it sort of improves things overall. Really, what SafeStake is an infrastructure and protocol, still in testing. We've got a testnet up that is testing all of this functionality. But really, in the end, you know, the concept that we're proving is a secure, reliable, flexible, decentralized way to stake ETH. So you'll see that it takes a lot of the goods from staking pools, combines this, allowing for some more flexibility, and because we're going to run on more than one node, and we'll talk about that, we can enhance security and reliability. So SafeStake does operate as a staking pool like Lido and Rocket Pool. However, there's a low barrier to entry. We have the minimum. You can stake as little as 8 ETH and also run a node. So remember, Rocket Pool had 16 on that. So we bring that down to 8, and then essentially there's the pool in the background that is going to fund the other 24 ETH to create the 32 ETH validator. In future versions, we are going to keep the low 8 ETH requirement to stake and run a node, but users will, if you want to not run the node and just be part of a crowdsourced validator and earn staking rewards that way, we are going to have that. So that sort of combines the low barrier of entry to stake and run a node with having a very little amount of ETH to just stake and earn rewards, nothing else. In our model, stakers, people that are going to, deposit ETH and run a validator, they're going to pay a fee to operators that are going to manage those validators on their behalf. And when you deposit into our smart contracts, you also receive the staked ETH token at a 1-to-1 ratio. And again, these are fully liquid and you can trade or sell them at any time for their current value. Oh, I'm sorry. And Parastate DAO will collect 10% of all of the validator and operator yields as a fee for using the network and the protocol. So again, pretty standard stuff there. What we do is, we're going to introduce things like redundancy, fault tolerance, and enhanced security via multi-node operation. So really, SafeStake is the first staking pool to implement what's called DVT. And DVT, distributed validator technology, is exactly that. It distributes the validator over multiple nodes, operator nodes, so that if one goes offline, the others can step in and respond. And we're going to get into this in a little bit. Our tech stack uses hot stuff consensus, Shamir secret sharing and BFT threshold signatures, as well as some other things combined, multi-party computation. There's a number of things in the background of the tech stack that all come together to do this. How does it work? Essentially, SafeStake takes the validator key and splits it into 4 key shares. So as you can see in the diagram, here's your key. Protocol comes in, splits those securely, encrypts them into 4 shares, and sends each share out to an operator. Okay. The protocol makes sure that 3 shares are always required to create a valid data signature. And when I say valid data signature, the signature is equal to that of the original validator key when 3 shares can come together, provide the secret, and get the information for the signature. So what does this mean? Again, one operator node can be faulty, offline, compromised, acting in a way it shouldn't, and the other 3 operators can step in and will step in sort of automatically and take care of the validator duties, meaning that it won't miss its duties and it won't be penalized. So really, we're talking about reward maximization here. So from a staking standpoint, if you want to be sure that your validator is going to be online and doesn't miss attestations or even worse, a block proposal, you just want to make sure that it's going to be there. It's going to be online. Here's a little bit about the architecture, and you guys can certainly explore this. It's a pretty in-depth diagram that we've got here, but yet, relatively simple. And the architecture makes it so that it's a redundant, fault-tolerant, secure environment. Really, one of the best things is that it's staying true to the original goal of blockchain technology, which is decentralization. All right, let's take a look at further. We talked about the operators responding in the committee if one's offline. The security. So let's talk a little bit more about the security. Again, we talked about the minimum of 3 key shares being required to produce that signature. But the other side of that is that any one operator in the committee, can't ever recreate that signature on their own. So that makes it an extremely secure solution. And also, the operators never have access to any deposit funds, never have access to keys. So it's a completely non-custodial solution where we don't We don't have anything. The operators don't have anything. Staker retains it all. And, you know, if one operator in the group decides to do something they shouldn't, act maliciously, try to double spend, do something, you know, something that the network isn't going to like, you know, it's going to quickly be noticed, and, you know, that guy will be taken out of the equation, and then the other three are going to run it. So the validator isn't going to get slashed. And really, what does that mean? The investment is protected, bottom line. So kind of the conclusion to all this, sort of to wrap it up, SafeStake is going to offer stakers kind of the best of all worlds. It combines, you know, that flexibility of having very little ETH to stake in, as well as the low barrier of entry to stake and run a node. It's liquid, and it provides that security and validator uptime at a very similar cost. So that's really what we're talking about today, guys. And just want to let you know that the DAO, or the Parastate DAO, we are running a SafeStake testnet. It's called Galileo, and we want to add as many validators and operators as we can, so that we can take this concept, prove it beyond a shadow of a doubt that it works, you know, and can handle the, you know, massive number of validators, and just run as it's supposed to. So we are encouraging everyone we can who's interested in this to go to this this URL here. This is our SafeStake project website, and you can go there and find out how to join, how to become part of our testnet, either as a validator or an operator, and become part of the future of ETH staking. So I want to thank you guys for taking the time to let me, you know, go through SafeStake with you. I'm going to kind of leave this fact sheet up here, and this sort of has a little bit about our tech. It's kind of a nice overall kind of card about what's good about SafeStake, and you know, what we're all about, what our roadmap is, and things like that. So I think at this point, take some questions. Did you guys want me to kind of look at the questions you sent me?
Yes,
answer those?
we can share the questions on the screen.
Okay, great. Yeah, did you want to do that? You want me to let you have it, or do you want me to do that?
Both are okay. Maybe you can do that. It will be more fun, I guess.
Okay, sounds good. Let me get out of this presentation. Before I get into those, does anyone have any questions about anything I went over in the presentation before kind of moving into these questions we gathered? No? Okay. So let's take a look at these. What kind of staking strategies are available, and what are their annualized returns respectively? That's kind of a big question. There's a lot of different staking strategies that are available, from centralized kinds of staking solutions that are things like a Coinbase, or others along that line, where we're talking about sort of centralized exchanges that are allowing people to buy and then stake their ETH. So those exist, to more decentralized staking solutions like the one we're offering, to staking pools, where you're pooling with other people to run validators. So the annualized returns are kind of tough right now to say. If you're running, you know, and you can always run your own validator too and just stake your ETH that way, which is probably the highest return. So probably, you know, 5-6% is pretty standard right now for you know, what it's looking like post merge, for if you're sort of running your own staking node in the pools. I'm not sure that it's that high. It's probably, you know, 3.5-4% maybe on ETH, maybe a little higher in some, but I think that's a good way to answer that question without being too specific, because those things are still being figured out post merge. What are, you know, how much your validator is going to make and all that kind of stuff. Okay. Now, if we're talking, let me take a step back on that. If we're talking about what kind of staking strategies are available with regard to SafeStake, so again, you can do, with us, you can do an 8 ETH all the way up to 32 ETH deposit. You can run your own, you can do anything there. And then in the future, again, and that would be a higher return than if you're doing the future, which is, you know, real small amounts of ETH and crowdsourced and that type of thing. It's going to be probably a little bit less. Okay. Will it follow OFAC standards? No, not necessarily. Kelly and I were talking about this a little bit before the presentation, but the concept of MEV and the maximal extractable value that you can get out of a block and block production, and the way things are ordered in the block, as well as the fees that people have paid in gas and in tips to, you know, priority fees to get their transaction included. This has led to, you know, what's going on right now with censorship, with, you know, specifically the Flashbots relays that are following OFAC standards and either delaying these transactions or omitting them from the block, resulting in censorship. So the thing with SafeStake is, and why I say no, is that we're not committed to any one MEV relay. We use lots of different MEV relays when the validators go out looking for MEV. So the vast majority of them are going to be, you know, not following OFAC standards, but you know, it's not that some of the validators don't run that client. So that's the issue there. But no, we are not. We are anti-censorship in the sense that we want Ethereum to be a free network, blocks included, and not censored based on what relay they go through. What if OFAC requires SafeStake to censor some transactions? That is a great question. We are not block builders, so that is so the thing to talk about here is the PBS relays, proposer builder separators, and the concept of proposer builder separation. So the validator that proposes the block can't build the block. A block builder does that, and that's subbed out, if you will, delegated out. What's the word I'm looking for? Outsourced. It's outsourced to a block builder. But the issue right now is that Flashbots owns and runs both MEV relays and PBS relays. So your builders are still going through some flash bots, at least some of the blocks being built, and there's where your censorship comes into play also. So it isn't really us that would have to censor that, it would be the builder, and that's what we have to worry about because there's not that many right now, and Flashbots has a huge percent of the market, making it a centralization problem, excuse me. Okay, what do you think about the problems that semi-centralization that POS poses to ETH? I mean, these are some of them. You know, the other ones are things like consensus clients being, you know, upwards of 60+% of the validator clients that are run out there. You know, there's that, there's Infura, there's things like, you know, every time somebody goes to Uniswap and makes a transaction, we've got Infura, you know, that's handling it. So there's a centralized thing. So, you know, again, what I'm going to do is send your group an article about, or a series of articles that our team has written about how this happens and how decentralization can be defended through infrastructures like ours, and specifically with an infrastructure like ours. So I'm not going to dwell on that. I know we're a little over time, and I appreciate you guys sticking with me. How to ensure that the proceeds of staking are released openly and transparently? Excellent question. Again, we're non-custodial, so that's not an issue. We never have any ownership of your keys. Operators have no access to your funds. The DAO never has access, and the stakers always retain ownership of all of that, and sort of ensures that their funds can't be tampered with, if you will. And what is the composition of Parastate's ecosystem? Are there any plans for future development? That's a big question also. Our ecosystem really is the DAO. So our community members, a lot like, you know, your community, that are running nodes that are keeping the SafeStake network up and running, and they're all over the world, and they, you know, it's true decentralization. So that's really what we're talking about. And yes, there are many plans for future development with SafeStake and continuing to take the protocol into the future, and just make it bulletproof, make it a complete solution. So I'm going to give these questions also to our team, if that's okay with you guys. I mean, that's my take on it, but my team isn't here to support me and give their take and their point of view. So if it's okay, I'd like to present these questions to the team and get their answers and send them back and let you guys hear from the entire team on some of these, if that's all right.
Okay.
Okay. All right. Yeah, so I'm all set. If you guys have no more questions, I just want to say thank you again. I hope you enjoyed it. I hope it was worth your time. I hope you learned some things, and it was a pleasure. And I'd love to do it again if you guys had the need.
Okay, I guess there is no more questions. And I want to ask, is there any questions from Tencent meeting? Dalong, Jolie, can you tell me, are there any other questions from Tencent meeting or?
I think right now there is no question from Tencent meeting.
Okay, now.
I have one last question about the key shares. Why SafeStake decide to split the key into 4 shares rather than 3 or other things like 5? Is there any conclusion? Any reason?
That's a great question. Okay, so I'm going to be completely transparent with you. I'm not a coder, and I don't know all of the answers in the background, but I'm going to take a guess, and I'm going to pass it along to my team, in that there is something to do with the need to have, 3 out of 4 operators, okay? And then I'm sure you can have more, but from a cost standpoint, for the validator that's going to run the operator, I think what they're going for is the minimum number of operators that need to be there so that the validator isn't paying, 6, 8, 10 operator fees, even though it might be a little bit more secure. But I'm going to pass that along to the team. That's my guess. I'm going to pass it along to my team and find out if I'm correct.
Okay, thank you.
Yes.
Okay, thank
Yes,
you,
and
Chris.
yes, and
Sorry.
Jan, you're.
Go ahead.
Yeah, I'm just responding to the chat. Yes, over there, the 3F+1. You can go to our websites and look at all of the formulas and things, and we're also going to be publishing our Git book soon. But you can get more of an answer there on the formulas and the algorithms.
Okay, I will do it.
Okay, I think there are no more questions. Thank you, Chris. Thank you very much. I think it's a big sharing. Thank you very much. Now let's wrap up the meeting, and later on we will post a recording on the YouTube and we will send you the link in the Telegram. Thank you.
Thank you so much, guys. I appreciate it. Have a good rest of your night.
Have
a nice day. Goodbye.
Bye.
Bye-bye.